when do we need our teams in for soccer? Because Ramsey doesn't say.
I don't know, cause like they're still trying to decide what day works.
Yeah.
But I already have a team. I did it this morning.
Okay. Yeah, no, it's supposed to be for Tuesday. But they're waiting to hear about the island, the Gross Islands.
Yeah.
That was class, right?
That was.
Grab your nearest partner. Start the problem on the board.
There's no problem with it.
What? Lies.
Sorry.
The problem.
My apologies.
I expected you to be able to see through that to this one. But it's also just the next problem in your sheet.
Hello?
Hello. Grab your nearest partner. Start working on the problem on the board. When you go get a pen, if the pen in any way doesn't work, throw it away and come and get a fresh new pen. No, first go check an old pen. If it does work, I don't want to throw it away. But there's a few in there that don't mark anymore, so if you have one that doesn't mark anymore, throw it away, come get a fresh new one.
Okay.
So, any pens that don't work, chuck them, I will exchange them. Yep,
Is this low enough?
throw it away. Nice. Grab a pen and a partner. Start working on the problem on the board. However, if the pen doesn't work, throw it away. Come get fresh pen.
It's the wrong booklet.
I think it's cereal. Okay, wait, I forgot how to go. So like,
1, 2, 3, 4, 5, 6. This. I don't want to install a new update. Go away.
Thank you, McCarthy. No, sorry.
What? What do you need? Lavina, why are you writing so high up?
Yeah, I don't know.
Okay, keep going. Nothing wrong with it. It just looked uncomfortable. Oh, and look. New erasers. Month left to go. I'm sparing no expense.
Where did I get the extra
Why is it over here?
Wait, guys, where did you get the extra editing? Oh, you made it too.
I like that. Ooh, you just made it.
Would this be an H3O equation?
What do you think? Don't forget everything you learned in grade 10. That's a classic acid and a classic base.
There's literally just no more placement.
Yeah.
That's all we learned.
So what does an acid plus a base make?
Water and salt.
There you go.
So H2O waters.
H3O.
How did they get the two?
Oh, that's fine.
No.
Oh, they did it right here. They did.
Yeah. It was 2H, so you get the extra H there.
Wait, it's water and salt, right?
Yeah. Now make sure your salt is correct and the charges balance.
So.
Because you don't balance the equation until you have your charges balanced in your compounds.
So it'd be H.
Like that?
No, it'd be H.
Oh, no,
H2O,
no,
right?
no. That's, first of all, that's not water.
Yeah, it's not water. It's like.
You balance the charges not by putting charges on them.
Wait, so.
Because you didn't do that in grade 10. How many sodiums go to self-pay?
2 moles. Do you know?
Oh, and I've got to put in. Hello, gentlemen. Why are you so late?
We're on time.
You're not. The bell rang at 9:30.
Go, we're on time.
These are not the robots you're looking for.
Yeah, that's fine. You can.
Grab a pen. Start working on the problem on the board.
I'll sit over there.
If your pen doesn't work, throw it away and come get a fresh pen.
Okay, what do we know?
But try the old one first.
We know that the volume.
That's it. Show us. Show us.
We know that it's 60 milliliters.
Oh, brand new.
We're in brand new word.
So 0.
Brand
point.
So we know this was 60, the volume of this.
Volume.
Wait, 60 mils.
But we want it in 0.0.
We can
Need
Zero
two,
six?
need two, so
yeah,
four
no, 0.06.
plus- Yeah, I need two, because it's two.
And then it's gonna be 2 molar.
Yeah,
What are you
so-
doing?
We could
No,
leave
but
it in
it's- it's pretty much-
milliliters, it doesn't
No,
matter.
we can't because it's molarity.
Yeah,
Oh,
but
that
we
is
could,
easy.
And
yeah, but
That's why they
if we use milliliters over here too, we can do it, because they cancel out. That's gonna be milliliters over milliliters.
But it's not milliliters.
150. Okay.
Is it not? You're wrong.
If you, it depends. You have to
That would
use,
be millimoles.
yeah, you can use millimoles.
I have no idea how
Uh,
they just appear.
Milli,
Sonia, how is it?
I'm
Okay,
just
I'll
saying,
grab
you
it.
could leave,
Rounds it for what?
you can just, as long as you use the same units in both of these, you're fine. You can't use
Sam, why are you so late? Oh, start working on the problem on the board with a partner. Grab a pen. If the pen doesn't work, throw it away, and come get a new one because there's a lot of pens that are awful.
Okay.
So actually, so I found what?
Multiply.
16 milliliters divided by 1,000.
Like that one's awful.
You already know that? Oh, that
60
is.
divided by 1,000.
How many mils in the line? 2. And then
I'm
multiply
gonna
by
drop
2.
it out.
That's,
Now I need you to divide this.
And what's that?
Times,
this divided by this. Right.
what do you get?
We're gonna number.
Times two.
Yeah, do it with the calculator.
48.
So, what do we actually find? What is
Yeah.
the
And then when we,
That's 5. It's 5 times
No.
25.
wait, no.
It's 0.24.
Is that the right?
Yeah. That's the same time. So I said no.
It's a bit there for last year.
Oh, actually, wait.
No, it's right.
The only thing is it's 2 here. I know it's not. But you must have just got Lavina.
Yeah.
0.0.
Did we freak it out? Did I freak it out?
Hello, grab a partner. Start working on the board.
It doesn't matter in the calculator.
Oh my
Yeah.
god.
I already did that. Allocations really hard. There was a
How you solve that?
Yeah.
Are we doing,
Okay. So,
Nia, grab a partner. Start working on the problem on the board.
I picked
Hello,
Jenny.
perfect.
if it's not, it's not.
Yeah, my partner is Lavina.
Your partner is Neha, because Lavina's already done it.
0.11.
Lavina can give expert advice at critical moments, but don't do it for
So
them.
if you get
Divide it.
Was that for
0.0441.
Wait, so
341 would actually be. Or maybe the last one. And then might actually be big.
What's going on here?
Actually, a 341 would actually be good. You have
I
like
can't place you left.
2 wings that also drop back in defense, so you can play defense and
under it, right? Like 300 units.
Oh, no, it's working.
Roll liters.
Okay.
Just under.
because we need a mess jacket, we don't really have it. Oh, that's true. But June's good as a wing too.
and now we write annihilation.
And like offensive. Oh, actually, wait. How's this formation?
What answer did you get?
Go like this.
We got 0.048.
Okay. Same?
Yeah.
Different? Okay.
What about we?
Where?
I will quickly do attendance.
Triangle. And then 2 strikers.
Okay. Now, how many moles do we have?
We don't know.
2 center mids and kind of defensive.
Etienne, Lavina, Tio, Josh is not here. Samuel's here. Ella, Sonia, Andrew, Nathan, Katie's is not here. Nicholas is here. Chance is not here. Glove is here. Max is here.
Oh, right
Ashley
there,
is not
2
here.
moles of
Niha's here.
I can be sent of it.
and 5 of NaOH.
Peter can
That goes
I want to be like that. I don't want to add it.
smaller.
I don't want Josh.
And
And then what else?
And 5.
And 5 of
And this has to be the same thing as that.
Perfect.
Let's see who's
And then you don't have to
Josh
get
not going today?
We add them together. That's what.
What?
yeah, Pete's nuts.
Sorry.
We understand.
Marvin.
We understand.
Zero.
I would
They're both on
have.
that.
No,
what do we got?
And then you divide it. And then you divide that.
I feel like you have to adjust. Instead of what Joey's been in now.
Maybe. And then you don't do anything else. You just
Put him at a 7, just like one.
Dude, what are you?
I definitely like Josh. Because Josh went in there.
Yes. Thanks, Sabina.
Oh, no. Oh, I feel
Okay, answer to the last one should have been 48 milliliters as a warm up. Next one. Adding in a little bit of Chem 12, a 250 milliliter sample of HCl with a pH of 2 is completely neutralized with 0.2 molar NaOH. What volume is required? Similar type of question. The key question though is B. If you use HCN instead of titrated with NaOH instead of HCl, assuming that they're both the same concentration, how would that change the volume of base? This is almost guaranteed to be on your next test or on the final. I like this question because it really shows whether or not you understand. It's not too hard, but it also explores a lot of assumptions that students make. So, A and B. B just requires a little calculation or a little sentence to explain the difference. Start with A, and you have your groups here. Andrew, you can join any group you like.
Perfect.
What? How did that happen?
So,
Do you know how to do
my
this?
partner is here.
Hold it. Did I? Where? Who did I not mark away? Oh, yes, I missed. Andrew, you're with Neha. Josh, you can join any group you like. And let me fix attendance.
I'm just waiting.
Grab your people, erase, and do that one. There we go.
No idea.
Okay, so
HCl is neutralized.
so we're gonna add HCN and NaOH.
Well, first we're gonna do A.
Oh, the question is.
So we have to write 250 let's write our little bit first. So NaOH plus HCl.
250 milliliters. What we're looking for? And we have 0.2 molar.
Okay, so what do we have?
We have our liters.
We have 250 so that would be
2.25.
yeah.
0.25.
Wait, could you spell that please?
It's on your notes as well,
Oh,
if
we're
you
trying to
need
find
them.
it.
HCl.
Is
Negative log.
And then, oh, we have pH in this.
I know, but pH is how we find the concentration.
Oh no, it's the oh, no, yeah, you're right.
The negative log of the yeah, 10 to the negative pH is equal to H plus.
Oh, yeah.
I
It's 10 to the negative 2. That is 0.02.
Yeah, as long as you find the
Yeah,
concentration.
that should just be 10 to the negative 1 is 1. No, 10 to the negative 1 is 0.1. 10 to the negative 2 is 1.
New.
Yep.
What do you do to pH?
What do you mean? What do you do? What are you trying to do with it?
We're gonna make it into a value that you use.
Yes, yes, you need to do that.
Negative H plus.
But there's a lot of people around here you can ask. Everybody has the equation down? Everybody has the equation down. But the
Which is equal to
That value.
What's the K of H? Oh, HCl is gone.
Is that H plus? Let's say equals.
Wait, what's the new formula? Is it supposed to be? Because to find the volume of this, we have to divide by Ka, right?
Is that right?
Isn't it this?
what's the Ka for HCl?
Very large. That's why I'm asking.
Why are you using Ka?
So that'd be clear.
I don't know what the stoichiometric point is.
Yeah. And how do you find concentration? From the data that you're given. You might want to check in with some other groups.
What's our molarity of HCl?
You don't have to do anything strange. There's a little bit of Chem 12, but
That's 2.5 as well. Unless that was
And then there's also 2.5 and then also.
Yeah, so I'm just divide.
check in with other groups. Go see what they're doing and then come back. Other groups have got it wrong.
That comes up with that.
So yeah, that'd be a good
And then B.
B, we did
B.
it.
If HCN were titrated with 0.2 molar NaOH, assuming it's the same concentration, how would this change the volume of base?
Oh, HCl and then B25, right?
But we have to convert this to Is it 0.025 or? No, 250 milliliter or 0.25?
Why haven't you finished filling out your schedule?
About the pH, because then either they can find it for concentration of OH or H plus.
Those will change some of what you calculated.
And then this divided by this. This divided by
I
this.
guess.
This is 2.2 already. So it's no difference.
You can check with others.
Yeah, it has no difference.
There
Yeah,
is.
no difference. 0.01.
Always check with others?
Let's go back to our original.
Ah, you figured something
Oh,
out.
so we were right.
Huh?
You figured something out.
How would this change?
Okay, but is this true?
Is it? I don't know. I'll check with other groups. You guys say no difference.
Yeah.
What's your volume? You should always write it out like volume required or something. Don't just circle a thing because that doesn't necessarily say that's your answer. Take it there. Write out your answer. Volume required is that sort of thing. So let them know. And then part B, once you have a volume.
Explain.
HCl is explained. Instead.
This is the same thing as before.
What was
Explain that.
Oh, and then now we
Same
have
concentration.
I don't know.
I would just change the volume of base.
Oh, is the
Oh, yeah, so
Is it still a one-way arrow? I think that's what it is.
We have 0 point.
But because
Oh, it would be
the next thing is both the same concentration, it wouldn't be the same.
Mr.
Sorry, what are you asking?
Yeah.
For B, is it the same volume?
Polarities are the same.
I am asking how would it change the volume of phase?
No.
Yeah, but is it the
Because
same volume for
polarity is
HCl?
Everything else is the same. It's just instead of HCl, you have HCN.
Oh wait.
Okay.
Whereas why you have it wrong? The other
Hydrogen cyanide or hydrocyanic acid.
put mole. Polarity is moles when
What do you mean?
You guys have mils there.
Wait, I wouldn't change anything.
You did a classic error, which is you kept it in mils. So technically, this is wrong because that times that doesn't equal 2.5 moles. It actually equals 2.5 millimoles, milliliters. But because you then divide by it later, your error cancels out.
So can I
So you get like there, you get it in milliliters. That is correct. So you either, if you do the table method, want to convert it to liters,
Oh, okay.
or use a method in which you use a ratio.
So
and
always
show
use
the
liters.
across. But yeah, always liters
on
to
the
do this
test is
because
after
technically that doesn't equal that mole.
Nick, can you
It's millimoles.
look up the Ka of HC
And you're allowed to use millimoles. There's certain work terms that I've used that all the time.
What's the concentration? That's got a little tip.
So I'm gonna, however, cheat and just copy out of you. So it was with 250 mils, so 0.250 liters, and that's in the wrong spot. And concentration.
But the last first team that we played yesterday was just like really aggressive, like
We need to find this. We can't just use this because it doesn't fully work.
everything.
How much the moles of H plus
Both
the
people in metal plate. Yeah, and just like people. Yeah, people were So, oh yeah, so this one's 0.2.
Oh, and I introduced an error.
Mr. Nicole, can you scroll up?
Yeah, this is in your notes.
So this
We've got it in your notes as well.
HC
Right.
and
Mr. Nicole, I accidentally left my iPad here. That's a really
I have not picked up an iPad. How long ago?
Last
yeah, do this
Like 2 classes ago? Check at reception in case someone turned it in. I didn't see one in here at the end of class. Like there was nothing on the table. One of them is indeed a week late or a week after. So maybe there is a difference.
I said there was a difference.
Excellent.
Okay.
How much of a difference? Calculate it.
One of them reacts
I don't trust that.
You have to do cancel that negative. You have to find out
CL is
You've got one volume in there. 250 mils.
Yeah, like we admitted that over there.
But it says how would this
Oh, are you doing part B now?
Yeah.
Oh, okay, okay. Yeah.
two
Okay.
if they're
Didn't see that. Perfect. Awesome. 2.5 times 10 minus 30. I'll even use your result.
are the same concentration, yeah, but if they're the same concentration, then it doesn't matter.
We like didn't really need to write a whole tiny table.
Takes the same amount of concentration over this. Oh no, I want to see this.
sense.
Okay, what's the question? Okay, each side. That's a strong base.
Wait, these are the formulas.
Yeah, that's strong. Perfect. We're question asks.
Okay, I'm gonna quickly pull around. Answer to part B. How does the volume of base change if you change the acid from a strong acid to a weak acid? HCN instead of HCl. Matt? Put it away in the bag. How's the volume of base change? It doesn't.
I have no clue what's going on.
Tio is madly calculating something. Are you in part B, Tio?
Yeah.
Excellent. So I am assuming by that you think it does change and you're just calculating it. So no change, change, working it out.
So did it
Yeah.
Changes. Do you know how much?
No.
Changes, working it out. Changes, working it out.
Yeah.
Yup, working it out.
Changes a lot.
Changes a lot. Why does it change a lot?
Because that's what my calculation is.
How did you get that?
I did.
Oh, yours is the concentrations are the same
That's not the concentration.
as 0.0.
Gleb, what do you think it changes?
It says same concentration.
Yeah, same concentration. So, if they are the same concentration, what kind
I thought it meant anyway.
what kind of base is that?
Strong.
Strong base. What kind of arrow do you get with a strong base? One way. So if we change this from HCl to HCN, will that change the arrow?
Yeah.
Strong, no. Will this still react with every hydrogen? Yeah. So if the concentration's the same, what would we change down here?
The volume.
Everything else is the same. The only thing we changed is the acid. We didn't change any of the numbers. So does anything about our calculations change? No. In fact, even if we had a weak base, they could still react in that 1-to-1 ratio. That is the most they could react. If it's weak, it just means it doesn't dissociate 100% in water. It still has the potential to react the same as a strong acid because all those hydrogens are still there. So for example, let's say we spill some, I don't know why I wrote that on the board. You spill some sodium hydroxide on the ground. Common lab problem. Dealing with strong acids and strong bases, we now have to wipe up the spill. If it's all over the ground, yes, I could add HCl and neutralize it, making it safer. But what happens if I add too much of that? What's wrong with this from a safety standpoint? Pardon?
You'll use up all that NaOH and a bunch of Na or HCl on the ground or what?
Yeah, you'll have a bunch of HCl on the ground. And what is HCl? It's very acidic. It's a strong acid. It's going to be super acidic. It's going to have a pH of like 1, 0 if it's a concentrated solution. And so, yeah, you neutralize the NaOH, but anything left over, you have that. But if I neutralized it with, say, sodium bicarbonate, which that can act as an acid, reacts with the NaOH, it's just baking soda, throw it on the ground. It will react the same way that any other acid would react. You can get the same amount of neutralization out of it, but anything that's left over is perfectly safe. It's just not going to continue dissociating. So weak things are just as, they have as much in their concentration potential to react. It's just that they don't react all of it right away. So HCl goes to H plus Cl minus. So this is 0.1 molar. What's this? 0.1 molar. Yeah. But if I have HCN and it does this, and I have 0.1 molar, what do I have there?
0.05.
Some other amount. You'd have to get the Ka out. So much less, whatever it is. Good guess, it was less. So we don't know what it is. But as soon as we attach it to something that we know is going to react, that's a one-way arrow because we have a strong base. If we have 0.1 molar with that, it's going to react with 0.1 molar of that, and it will react all the way. So this matters kind of only when it's by itself. When it's by itself, it's kind of unassuming. It reacts a little bit, doesn't really care. But if NaOH is around, it will react with all of it. HCl just always reacts regardless. Throws it all over. It's a strong acid, dissociates right away. So I like this question, and it tends to crop up on things. Because what this question is trying to get at, no, I don't want that pen, is do you understand the difference between a strong acid and a weak acid in terms of their behavior? They react with things in much the same way. Their only difference is that they're weaker in solution on their own. They don't immediately separate into their, they have an equilibrium. We have already done versions of these, use HI, high, and KOH, write the formula equation, complete ionic equation, and then a net ionic equation. So a bit of review. We did it when we did our titration curves.
Can you wait for us to get all that stuff down
Being recorded, you can read it later. We gotta move. No, it's knowledge. It's all in here now. All in here. All in here.
Is there
It's there, and for the purpose of going back later, I believe this was 48 milliliters. Yeah, I think it was. So, and okay, strong acid and strong base. We're going to use HI and KOH. Start with it 10. What does the formula equation look like?
HI plus KOH goes to KI plus H12.
What kind of arrow? One way or two way?
One way.
One way. Goes to
KI
KI
plus H12.
plus H2O. Complete ionic. Let's see, we're going to pick Josh. That's what he's. What is. For anyone, what is complete ionic? What do you do with it? Break it up. So break them all up. Yep. Break up all the strong ones. We started off saying it's a strong acid and a strong base. break it up. How does HI get broken up? H plus I minus plus plus OH minus goes to what kind of K? Yep. I minus plus nope. Just H2O because all of these are aqueous. And water is a liquid, so we don't break it up. So I'm just going to do that. Oh. But water is a liquid, so we don't need to break that one up. Net ionic equation. Then, Gleb. H2O.
Wait, no. Yeah. Goes into K plus I.
I'm so confused. Gleb, put away whatever you were working on. Focus on this. We already have the complete ionic. Cancel out what's the same on both sides. What do you got left? Pardon?
Oh, that, yeah, that.
Which is?
H plus OH minus equals H2O.
Excellent. For every strong acid, strong base equation, this will be the net ionic.
No idea.
Every strong acid is equivalent to its H plus. The only possible exception to that is H2SO4, which is that for its first step, but it has the potential for a second weak acid, so it can get a little more complicated with sulfuric acid. But for most strong acids, it's that one. Okay, weak acid, strong base. We did those, and then a strong acid, weak base.
Wouldn't you put the H2O first then?
Pardon?
Wouldn't you put the H2O first for the net ionic?
Why didn't I put the? Why would I put the H2O first? I think I know what you're doing.
Yeah.
When we had solubility equations, we always put the solid first.
Yeah.
Those are just for solubility equations.
Wow.
Yeah. For this one, you just
Well, I
keep it
had
as
it,
it is.
but like you just like shook your head when I said H2O.
You said that you put an H2O. It was on the other side. It was confusing. Okay, I'll give you then, since you're claiming that I was unfair, I will let you pick the next one. What is your favorite weak acid?
H2. Oh, wait. Let's do FeH2O.
Oh, you jerk. Yeah, okay.
3 plus.
That's lovely. That's beautiful. I like it.
I don't.
Yeah. What's the strong base you're going to do with that?
No, that's 3. Strong base. Oh, yeah. I'll just do it.
Anyway, okay. Nice easy base for that acid. Excellent. Go through that for your weak acid, strong base.
Would KO be a strong base?
Yep. Cool. Do you want to change it to that?
Yeah, let's change it to KO.
Let's change it to KO. That's right, yeah. Let's just get a little, let's play with it a little bit, yeah. Okay. I mean, it doesn't make it harder. He could have also chose strontium hydroxide, which then it would have had actual balancing. Pardon? Who said that? Fe has a charge of what?
Oh,
Why would Fe have a charge of 6?
Well, why does the 6 go down? H2O.
Oh, this is on your table. You can just look it up. Look up its product.
Oh, does it go to F?
That's our +3 metals. I like it because it's good callback, good review.
No, it'd be F. H2O,
no, it's H2O.
Oh,
Fe, H2O.
that's
Oh,
weird.
and I think it can move 2 electrons because it's still 2 electrons.
I think you just move the K
So
away.
it can be the K.
So it has a +5.
Oh, that's a strong base.
Oh, sorry.
Yeah.
Because you chose that, we shouldn't have a plus in there, right?
No.
But
Because we can't get that off the shelf.
Uh-huh.
So let's say it is this, but originally when you took it off the shelf, it was iron +3 nitrate.
Can we not?
Can we,
Yeah,
can we
just pick
choose
a
a different
normal
one?
one.
Can we pick
no, can we do? But Mr. Neufeld, how
No, I want to change that. I'm just gonna say I want you to think about that.
I don't even know how you.
I don't know how to.
That's supposed to be H2O.
that, yeah,
So
Mr.
there's no
Neufeld,
6.
Mr. Neufeld,
Yeah.
how many H's does F does it give off?
1.
Because it's +3, so I would think it can.
Is
So
there
it-
no more
No,
stuff?
it's, what does +3 have to do
Is
with
there
it?
still 6?
So you just have.
Because if you give 3 H's,
It doesn't have
you
3
go back
H's.
to neutral.
Technically, hold it. That's a 6 there. I erased
Yeah.
that. Technically, it is 12 H's.
Yeah, but if it loses 3 of them, it becomes neutral. And I thought. That
But acids and bases aren't about becoming neutral.
Because
It's on your table.
H2O is neutral, so the charges come from Fe.
Um, yeah, it does have a +3. Charge will come from Fe.
Because it's reacting with a strong base, it reacts with all the H's. So
No, it reacts with all the H's that can react.
and only one.
This is a monoprotic acid.
Oh, okay. This is.
Metals +3
Yeah, but oh, and the extra O.
are monoprotic. Do you remember? I think it was earlier in this. No, it was the previous KBAT. I said +3 metals are acidic. We spent some time writing some of those out. They're all monoprotic. They only give off 1. Their product can be found on the table, so they are messy to write, but you can find them there.
Does that split FeH2O6?
Yep. But the product is given in your table. You just look it up.
No, but does it like
H2O
in a complete ionic equation you split it?
No, it stays like that.
Because it's a weak acid, right?
Because those waters don't go anywhere except for a tiny part of them.
Yeah.
Okay, Sonia.
No! Why?
Because the random person picked you. And I want to give you more points.
I don't like 4 points.
Currently, you have 8 points. Oh my God. You only have 8 points.
For what?
I have to ask you a lot more questions.
No, I'm okay.
Gleb has 13 points.
How many do I have?
Who said that? Josh? Josh has 12 points.
How about me?
Yeah. Where? Andrew has 10. Okay, at 10 is 10. Lavina has 9. Theo has 11. Josh has 12. Samuel has 8. Ella has 11. Sonia has 8. Andrew 10. Nathan 7. Oh, Nathan, I got to ask you a lot more questions.
okay.
Nicholas 13.
Don't need to.
Gleb 13. Max 8. And Neha 5.
Wait, so who has the most?
13. Whoever has 13.
I got asked 13.
Okay, go.
No, okay. H2O6 whatever plus KOH with the charge of +3
Excellent.
goes to H2O
Oh, yeah, I'm not done yet. So go. Sorry.
plus don't oh god. I said KFeH2O5OH.
Because we didn't put the nitrate on here, you're right, that came over there and reacted, but it didn't have a partner, so just what's left over
From what?
from here.
The
The cat.
So would it be
The K. So we got that.
That's not what it says on the
Oh, no, no. And then what was the other part you said?
I said.
Oh, F-E-O. I think I got it wrong.
H2O.
Yeah, no, H2O is good.
Okay. No,
Look at your table.
for that. My table. Why?
Yep. What is when this gives up a hydrogen, what does it become?
Sonia.
What's its
Oh.
conjugate base?
Sonia, it's everything but the K. So it's like the F-E-H2O.
FeH2O plus what?
Don't listen to Gus.
confused.
Don't listen to that.
Okay.
Look on your table.
Yeah.
Find this.
Okay. I see it.
You see it. What is on the other side of it?
FeH2O5OH.
What's the charge?
2.
+2. That's it.
I don't like that.
Yeah. We didn't pair it with another negative to go with the positive, so that's what we're stuck with. But one hydrogen comes off, that's the reactant, that's the product. This is a base, that's an acid. This is a terrible question because it is needlessly complicated, but it is a nice review of +3 metals. I am going to, below it, if we were to give a nice version, weak acid, we could have something like NaH2PO4. Let's do both of those. So, products of that one. Go.
Still me.
No, everyone. I'm going to ask someone else in a second.
H2O
Yeah.
and
Oh, you're volunteering right away? H2O. And then stop, because I want everybody to take a chance and figure out what is that going to be. Yeah, I've got to stop asking this randomly and just start picking on the people with the lowest amount of points.
Why do you even have a point system?
wait, Liv,
Why do we even have this lever?
would that lose all 2 of its H's?
What do you think?
I think yes, because that makes it easier.
It does.
Nick disagrees with you.
And
Now you have to fight.
later, but like
No, not physically fight. Nick, do you think it loses both H's?
No,
Why not?
because there's only one H in the KOH.
There is only one OH,
That reacts.
but
you can make 2 KOHs.
you can balance later.
I don't know. Yeah.
We don't balance reactions by saying how many are there. We balance after the fact by saying how do they react. Is KOH is strong, right?
Always has water and
Did I do the candy analogy?
no.
Okay. I'll do it after. Let's get a product. Samuel, what do we got here?
KPO4.
PO4 is good. K is good. How many of those is it going to react with? How many hydrogens are here?
2 of 3.
So you took 2 off. So how many of those K's are going to go on this? 2. And then what's left over? Na. NaK2PO4, because that's -3, so we need plus charges. I've never shown you a compound like this, but they're really good for crystallization stuff. So we've got 3 positive ions, alkali metals, with our -3 charge. I like this. You guys are coming up with some really nice complicated examples. Now, to go back here,
2 KOHs.
how many of you only reacted with 1 hydrogen? Nicholas, your hand should be up because that's your entire point. But it actually reacts with both because what kind of base is this? Strong base. It takes all that it can. It is strong. So for example, acid-base reaction, and you have 1H. This is like candy, and you are weak. And so, no, it's mine. And I take all of them because I am strong. Neha is H2. Very happy with her H's. But I am a strong base. I would just take both of them, and it would just take 2 of me. Come. Take the other one. See? There's now 2 of me. The resemblance is uncanny. Thank you. And for Ella. Take both of those, do the complete ionic equation, and then the net ionic equation.
I don't have
I
space
just
for it.
wrote down.
Pardon?
I don't have space for it.
But it's smaller.
But I didn't know we have to do that.
But now you do.
Okay, so I did.
Okay.
I did.
It's too bad. Find a piece of paper.
I have it in my head.
You have it up?
In my head.
I have lots of extras of the entire sheet. Just come and get another one. There.
No, I have it in my head.
Nope. Right down.
But that's
There you
such
go.
a paper waste. That's
How is it waste? I already have it. Nobody's using it. It's literally putting it to use. It's the opposite of waste. You don't use it
so
as
you
waste.
make me all this paper for one project.
Yep. Remember, I'll cut down an entire forest with the squirrels, little chipmunks, birds singing, and crush them beneath the weight of the bulldozers to make your grade go up by 0.1%.
You know, it's like
Yeah.
really wasteful when all you have to do is click a button on a screen and you can make it go up by 10%.
It's very clever. You rely on the reputation of the school. If you graduated from here next year, we just gave everybody A's, what would that do to your high school diploma?
I thought the reputation of the
complete
school
ionic-
depends on that.
Make it worth
It does, and it also depends on that your grade is how we accurately portray it. If we told the university that you have an A and you walk in not knowing the material, they're not going to trust our marks anymore.
So if for
Yeah.
the complete ionic equation, is it like FE6?
NP6?
No, FE6. Or is it just
Oh, I see. I didn't know FE. No, it's not FE6. Does this separate? No, this is some weird covalency thing. It's +3. There's no negative charge. That would stay. So, given you asked the question, then, Andrew,
Yo,
what do you have to begin for the blue one?
then you have to do FeH2O 6 3 plus
3 plus plus.
plus K plus OH minus. And then the arrow thing
Yep.
It's
is
gonna be the ions.
H2O.
Yep.
H2O plus K plus F-E-H2O 5 OH2S. How do you know when, like, the first thing just sticks off?
You separate all the things that, like solubility rules, they dissolve 100%. You separate them. If they're a strong acid or a strong base, you separate them.
And how do you know that you don't separate the OH?
No, that's not correct.
Which we did separate the OH.
Yeah.
Oh, and the Fe, H2O5? That's not a hydroxide. That's just a dangling group left on the iron. So it's not a +1 or +2 metal. It's got to give you your point, Andrew. So Nathan,
Mm-hmm.
getting you up in points now.
I don't have that yet.
Oh, that's okay.
Okay, we're just gonna do it.
We're just gonna do it. What would separate in here?
That's a great question.
Sodium, soluble with everything, nothing, something,
Everything.
everything. So we'd separate that one.
Yes.
Okay, so start us off.
Na
Oops, that was supposed to be blue. Na
plus
plus.
plus.
Now, earlier when we did equations, this is a weak acid. Do we separate weak acids?
Yeah. No.
No, don't listen. Don't listen. They said both
No.
answers. No, okay. So what do we write here?
H2PO4.
Charge?
2 minus?
We only took off one sodium.
Oh, then 1.
Minus 1. Excellent. Plus?
K plus,
Yeah.
plus, OH minus,
Excellent.
arrow,
Mr. Neufeld.
H2O,
Hold on,
plus,
do it. Oh, hold it. Did we balance?
No,
no.
it's 2 KOH.
No, Nathan? Balance.
That wasn't my question though.
That's okay.
Well, you should take away whoever's point was that one.
Yeah, I'm going to. Well, no, you can balance. It won't be that hard.
Okay.
I'm going to give you an extra point right now.
Oh, I don't, okay.
There you go. Because you're catching up now.
Fantastic.
Yeah. 9 points. Yeah. Woo.
Great.
Yeah. How many of these will be needed to react with that one?
2.
2. So we need a big 2 there. And these are now getting in our
Oh, well, yeah. just
way.
get rid of those.
So let's fix their color. Nope, that's not what I wanted. Line color. There we go. Perfect. So if there was 2 KOH there, boom down here, what do we have to do there?
A little 2.
Put a little 2. What about this one?
Throw a little 2.
Excellent. Well done. Yeah. Now keep going. Right there.
You pointed at N,
Also, don't you need 2
And
H2O now to get up?
2, K2.
Yeah, you did.
No.
Not K2.
Plus,
Plus.
K.
How many of them?
2 of them.
2 of them.
Plus PO4.
Plus PO4. What charge?
Minus 1.
We took
Minus
3 things
2.
off.
Minus 3.
Minus 3. And then someone rudely spoke, trying to keep balancing. You balanced over here well. Is
No,
the,
it's not balanced.
does the hydrogens balance out on this side?
Probably not.
Probably not. How many oxygens are over here?
1.
Nathan? 2. So how many needs to be here?
2, so put a 2 on the.
Put 2. Then we got 4 hydrogens. 1, 2, 3, 4 hydrogens. We're good. Nicely done.
Can I have another point?
No way you're giving him.
Oh, you're in double digits now.
How did it sound?
Okay. Now the net ionic equation. Josh. That was a big sigh. Cancel out what's the same on both sides. Just tell me what's left.
So some just H2O.
Sorry, what?
So the first one just H2O?
H2O?
Well,
No,
K
this
cancels
one.
out.
We're
Yeah.
going from the complete to the net.
So then it's cross out everything that's the same.
Everything that's the same on both sides. What's the same on both sides?
Oh shit, wait.
What? No? What?
K plus.
K plus.
Yeah.
That's it.
That's
This is different from that, so you can't cancel any of that. So what's left?
FE HO2 6 3 plus OH minus and then the arrow H2O plus FE HO2 H2O 5 OH plus
Excellent. And the other one, who needs points? Sonia. Well done. What's the same on both sides?
NA
And?
and on the K's.
Yep. Anything else?
No.
Okay. What is it then?
H2PO4
H2PO4 minus.
plus the OH, the 2 OH.
2H minus.
Goes to the H2O.
That one, that should have come down, so we need to keep that. Plus
PO4.
PO4 minus 3. Excellent.
Wait, can you stop there for a second?
Yeah. Who else needs points? Dun, 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 dun. Randomly, Max.
Yeah.
Pick a strong acid that is not H2SO4.
HCl.
Sure. And a weak base.
Weak base. HCl.
No, not H2O, because it's in water.
F.
Oh, nice. After all those really difficult ones, this should be nice. Formula equation, complete ionic equation, net ionic equation, HCl. But we can't use F. What kind of F? Pair it with something. Can't be HF, that's an acid. Put a spectator ion on it.
Can we do FR?
NaF minus. Oh, Fe.
No, you had F minus, so you need to put like a spectator on it. Don't do Na. It's,
CHN.
no. You don't look at your periodic table. You want to pick something that's a spectator, right? Or your so like any one of those would work.
Do lithium.
KF. That'll work.
How about Mr. Rufel? Would FRF work? Or
R?
FR, francium?
Oh yeah, francium fluoride.
Yeah.
Yeah. You'd also have the most expensive weak base in existence, given that it's radioactive with a half-life of like, I don't know, 20 minutes, and it disappears like that. So if you have some, it's worth a lot of money for a few minutes. Yeah. Because it costs a lot of money to produce. You need a particle accelerator. Yep. Your question?
No, I'm just.
Okay. Formula equation, complete ionic equation, net ionic equation. I'm gonna. I'll ask random people again. Those. Oh, Neha. You only have 5 points. I should ask you like 7 questions in a row. I will ask a completely random person, like Neha. I mean, it's somewhat not fair because you came in late, so that you're behind on points. But we'll get you caught up. Don't worry. I'm sure you were worried.
How did you get H2O? What is the
And I am going to insist that we get all these written down before you go. And then I have some homework, specific homework for you. Yep, 2 minutes to get it done. It is easy. We've already done it. We've actually literally already done this.
Do it right now then.
Oh yeah, we did just like 2 days ago.
Yeah, like if you turn back, I think this exact equation was used as an example for our strong acid, weak base, and we wrote down the net ionic. I'm guessing, but I think so.
Yeah.
Two. Back. We'll just start it off. Neha, what are the reactants?
HF and KCl.
Yeah. HF, not HF. Those two right there.
HCl plus KF and then HF plus KCl. That's what I meant.
Goes to HF. Perfect.
Yeah, that's what I was saying.
Excellent. KCl. Perfect. Can you do the complete ionic?
H plus Cl minus plus K plus F minus goes to H plus.
Nope. Weak acids don't separate. This dissociates 100%. That dissociates 100% because of solubility. But weak acids don't separate. Those stay the same.
Okay.
So that would just be HF. But you're on a roll, so
Plus K plus Cl.
excellent. And then what would the net be?
Is there any charge on HF then? Or
No, no charge.
Okay. And then the net ionic would be, wait,
What's the same on both sides?
Cl and
Excellent. Before you go, this page, calculate the pH of a solution with a strong acid mix. You've already had these in your Hebden. I would like you to arrive with those two done for next day.
Can you go up next class, or can you go to the thing again?
Yep.
Wait, both of these questions?
Yep. You've already done them in your Hebden. Very similar ones earlier on.
No.
Oh, no. You did all three of them. You get 3 points. So we're...
Oh, yeah.
Excellent. So the very next page, do those two problems. Thank you.
Thank you.
Hold, this was F.
Thank you for the point.
So F. Next block is A. No.
FD.
FD. Why was I thinking it was Fab? That'd be a great day. Because it would be Fab. Yeah. It would be fabulous. You're welcome.
Did you check if it's under your
Live and see when the minutes come.
Bro,